Okay, so let's start with our main topic for this tutorial. Now, mathematical numbers are represented with a sign and a value, or also called as magnitude, in which the sign indicates if a number is positive or negative. So for example, 23, ibig sabihin if walang sign, walang negative sign, walang positive sign, so it is immediately identified as a positive integer. Another example, positive 176. So it indicates this is also a positive number. Okay, next example. We have here this number. So as you can see, if there is a dash or negative sign before the number, it indicates that the number is a negative number. Now, this fashion of presenting numbers is called signed magnitude, since the leftmost digit is used to indicate the sign and the remaining digits, which is known as the magnitude or value. So for example, negative 247, So for example, negative 274. The sign here is, of course, indicates this sign if it's negative or positive, and this number here is the magnitude or the value. Okay? Now, the question will rise on how do we represent signed binary numbers if all we have is 0 and 1s in computer system, right? Data in computer is represented by binary numbers, which is 0 and 1, right? So how? Okay? Now, so far, here's what we know. Binary digits has two values, 0 and 1. Sign also has only two values, positive and negative. So that's so far what we know. Okay, now in representing signed binary numbers, we can use single bit to identify the sign as being positive or negative in value. The most significant bit, or MSB, is used as the sign bit. Okay, so let's have an example of MSB. So let's say the binary number 0001. This is the MSB, or the most significant bit in this example. Another example, 1000. 1 here is the most significant bit of these given binary numbers. Okay, so I hope it's understandable what's the meaning of MSB. So basically, let's define na lang what is MSB. MSB is the bit in a multiple bit binary number with the largest number or largest value, I think. So here in our example, the first one, 0, is the MSB. So it means that it has the largest number, or it is the largest number. Second example, 1 here is also the largest number. Okay, now, how do we identify if a certain binary number is negative or positive? Now, in signed binary number, it is actually represented with a bit 0 when positive and 1 bit if the number is negative. So again, 0 if positive, 1 if negative. And then, the remaining bits in the number are used to represent the magnitude or the value of the binary number. Now, since we cannot feed negative or positive signs to digital system, there are 3 common ways to present negative numbers within the computer. We have the signed magnitude representation, 1's complements, and 2's complements. Okay, let's start with signed magnitude representation. Okay, let's have here first the positive sign binary number. So, like what I've said kanina, if a binary number is positive, then the representation of it being positive is 0, right? So, let's have an example. We have here 1, 0, 1, 0, 1, 1, 0, 0. Now, in this example, this is the positive sign bit. This binary number represent that the other value left or the magnitude bit is a positive binary number. And this example here is a 8-bit word. We can also write 6-bit word and 4. We can also write 16, 32, and 64, so on and so forth. Okay? So this example here is equals to positive 53. Okay, next we have the negative sign binary number. So another example. This is also 8-bit word example. So we have 101 01101. So like what I've said kanina, if 1 ang MSB, so ibig sabihin it's negative. So this is a negative number. And the rest, yung mga naiwan na bit, is the magnitude bits. So if we're going to calculate this one, the equivalent is negative 53. Okay, so that's for the signed magnitude. Okay, let's have an example here. Negative 15, 10 as a 6-bit number. So let's try to write this decimal number to binary. So 6-bit daw siya, so we're going to write down 6 binary numbers. So we have 15, so this is going to be 1, 2, 4, 8. So 8 plus 4, 12, 13, 14, 15. Okay, so that's 15. But since it's 6-bit, and ang nalusulat natin dito is 4 lang, so we're going to add another 0 and 1 here for the sign. It is 1 kasi nga, this is negative 15. So this is now the value of, or the decimal value of, the decimal number negative 15. Okay, next, positive 85 as 8-bit number. So we're going to convert 85 or positive 85 to binary, and 8-bit number or word siya. So kailangan natin isulat is 8 bits of binary number. So 85 daw. So this is the result. So 1010101. And the MSB here is 0. This is the sign. This shows that the binary number is positive. Okay, so you just do the math. Now, note that for a 4-bit, 6-bit, 8-bit, 16-bit, or 32-bit signed binary numbers, all the bits must have a value talaga. Therefore, zeros are used to fill the spaces between the leftmost sign bit. Okay? So, yeah, that's for the sign magnitude. Okay, let's proceed to our second topic, which is the ones complement. So this is the other way of feeding negative numbers to the computer. Okay, note that, okay, positive binary numbers are not unchanged, and negative are represented by taking ones complement of unsigned positive number. Okay, let's have an example. So let's have a negative binary number. So we have 1, 0, 0, 1, 0, 1, 1, 1. And we're going to convert this binary number to its ones complement. Now, how will you do that? We are going to replace all zeros with ones and all ones with 0. So, paano yon? Okay, so this example here, ang 1, ilisa ni mog 0, ang 0, ilisa ni mog 1. So the result is 0, 1, 1, 0, 1, 0, 0, 0. So this is now the ones complement of this binary number. So as you can see, it's just really easy. Okay, so now let's proceed to the 2's complement. Now, to find 2's complement of a binary number, first we should find the 1's complement and later add 1. So it's really easy, right? But before that, before we go into the explanation of how to do the 2's complements, I'll just show you first the rules for binary additions. So these are the rules. 0 plus 0 is equals to 0. 0 plus 1 is equals to 1. 1 plus 0 is equals to 1. And 1 plus 1 is equals to 10. Where, for this one, 0 is the sum and 1 is the carry. Okay, let's have an example for this rule. Let's say 0, 0, 1, and 1, 0, 1.
Okay, now let's add these two binary numbers. First, we're going to add 1 plus 1, and based on the rule I have provided kanina, 1 plus 1 is equals to 10, right? So we're going to put 0 here and carry 1 here. And then we are going to add the carry binary with 0 or by 0. So 1 plus 0 is equals to 1. And the result, we're going to put it here above this 0. So then we're going to add the carry, just 1 with 0. And the result is 1, right? Then we're going to put it here. And then we're going to add also the remaining binary numbers. So 0 plus 1 is equals to 1. Therefore, the result in adding all of these or these two binary numbers are 1, 1, 1. Okay, so that's how you apply the rules for binary addition.
Okay, let's have an example on how to find the 2's complement of a binary number. So let's say find the 2's complement of negative 33. So first step is to find the 1's complement. And by doing that, you have to find first the decimal, you have to find first the binary number of 33. So this is the binary number of 33, and then convert it to 1's complement by changing or replacing 0 by 1 and 1 by 0. So then this is now the 1's complement. And after that, we are going to add 1 to this 1's complement. So it's going to be 0, 1, 1, 1, 1, 0, 1, 1 plus 1. And then we're going to apply here now the rules for binary addition. So 0 plus 1 is equals to 1, and then just bring all down the other binary numbers. So bring down here 1, 1, 1, and so on and so forth. So now this is the 2's complement of negative 33. Okay, so I hope you get it, and if not, then you can just rewatch the whole tutorial. And for the next video tutorial, I am going to discuss the addition of signed binary numbers and also the subtraction using 1's complement. Okay, so that's all for our video tutorial today. If you have questions, clarifications, violent reactions, you can just PM me on Messenger or chat on our group. And further informations or announcement will be posted on the classroom. So that's all. Thank you and enjoy the rest of your week. Bye!